I feel like Doc Brown in Back to the Future. Keep the camera rolling. The question, no, this sucker's electrical, but requires a nuclear reaction to generate the 1.21 gigawatts. Anyway, the question was, and this is a fantastic question, what are the odds of these percentages not summing to zero? And actually, the answer is in the question. What are the odds? What is the probability that the sum of the errors will not be zero? And the answer is in the question. There is no chance of it not equaling zero because it has to equal zero. It's a 100% chance that they will equal zero. His chance is his question was, what's the chance they don't?
1% because of rounding.
We'll say that again.
Because of rounding.
No, if you round properly, it'll always sum to zero. If people round slightly improperly, it might not, but that's not the math failing, that's the rounding failing. It's 100% likely that they will sum to zero, so 0% chance they won't. Go ahead, Gabe.
So there's control to say everybody, we have to do this 320 times and do it for like, I don't know, 6 years every day.
Yes.
Do this. Is there any chance of everybody rolling sixes for that whole 320?
Yes, of course there's a chance. It's just not a very big one. Now, what's going to happen there, Gabe? I love this question. What's going to happen? Remember the hit? I wish I hadn't erased it now. When I showed you a histogram before of our observed results compared to our expecteds, what happened was there were some bars above and some bars below. What would happen in that case is you'd have one bar through the roof and a bunch of little bars at the bottom. But all that extra through the roof is cut off and spread equally.
I know, but not like every controlled one in his own experiment. So you don't add up every other one.
I'm not going to understand. Oh, so don't make it 320, make it 1. It's hard to analyze that. It's kind of like when I first start this spreadsheet and it's on the 1-3. It's like, it's not 1-6, but you haven't proven anything because you haven't seen enough trials. You have to accept such a wide margin of error that a sample size of 1 doesn't tell you anything. Is that fair? You're asking a very 244 question, which I love. Are you thinking Math 244 at some point? Yes. The correct answer is the head going this way, not this way. No. 105? Oh, I understand. The question you're asking is one of margin of error shrinking versus being large versus small. When you have a small sample, you have to accept the large margin, which means there's no reason, even if you don't roll any, that you can disprove anything. And I know that's not a very satisfying answer. It's a very mathematical reason, and that's why I mentioned 244. We spend about a day describing just that. Great question. Scott, question?
What's the probability of our take-home exam being posted by this weekend?
I hope it's pretty good.
Okay.
I'm hoping to get it done this weekend for you. Yeah, great question. Let me turn this off. I guess we're done with this now.